Picture this. You're out in the desert, miles from the nearest light. On screen, that bright ribbon of the Milky Way cuts across the sky like spilled glitter. And that glow is just a sliver of a galaxy with something like 100 to 400 billion stars.
And we've learned something else that changes the stakes. Stars don't tend to be loners. On screen, that rising curve is real. By mid-December 2025, the NASA Exoplanet Archive listed about 6,065 confirmed exoplanets, and the count keeps ticking upward.
Sure, and that's just the worlds we can detect with today's tools. When people say billions of habitable planets, that depends on definitions. But even conservative work suggests the Milky Way could host hundreds of millions of potentially temperate, rocky planets.
So, here's the myth we're busting, that with numbers like that, we must have neighbours, and we should have noticed by now. The galaxy should feel like Times Square on New Year's Eve, noisy, crowded, impossible to miss.
But when we actually look, the vibe is what you see on screen. An empty library with one lamp left on. Quiet. Unanswered.
That tension is the Fermi Paradox. We have a universe with deep time, about 13.8 billion years, and a galaxy with a staggering number of places to live. And yet, we have 0 confirmed contact and 0 confirmed technosignatures.
So, are they hiding? Are they gone? Or, and this is the one that sticks, are we actually alone?
Or we're just not very good at looking. But I'm skeptical of the crowded galaxy certainty. Wanting it isn't the same as showing it.
Right. And that's the key edit. The myth isn't aliens exist. The myth is, if they exist, we should have found them already.
So today we test that claim. The hard numbers, the searches that came up empty, and the best explanations for why the sky keeps its mouth shut.
Let's strip the sci-fi gloss off this. The headache starts in 1950 at Los Alamos. Enrico Fermi is walking to lunch with colleagues. The conversation drifts to flying saucer talk in the news, and he drops a question that still stings. Where is everybody?
It lands because the back-of-the-envelope logic is uncomfortable. With even modest interstellar travel and enough time, models show a civilization could spread through the Milky Way on timescales far shorter than the galaxy's age. Not instant, but not billions of years.
But they aren't here, and we've been checking.
For a long time. Modern SETI really begins in 1960 with Project Ozma, pointing radio telescopes at nearby sun-like stars. Since then, we've scanned radio bands, and we've also looked for brief optical flashes. And as of 2026, still no confirmed technosignature.
To be fair, no confirmed is doing important work. We've had intriguing one-offs. On screen, that wow printout from 1977 is the famous example. But it never repeated, and without repetition and verification, it stays a mystery, not a discovery.
Okay, devil's advocate. The galaxy is huge. Maybe we just haven't looked in the right places, at the right times, in the right ways.
That's the needle in a haystack argument. We've sampled a tiny fraction of the possible search space: sky coverage, frequencies, time, signal types. It's like dipping a glass into the ocean, finding no fish, and declaring the sea empty.
I still hate that analogy, because it assumes civilizations behave like random fish. If anything is out there and old, you'd expect some of them to build big. On screen, a Dyson sphere is the poster child. Structures that capture a star's energy. And we've looked for the telltale waste heat glow those projects should leak. And we don't have a confirmed one. Surveys in the infrared haven't turned up anything that clearly screams star-scale engineering. and galaxy-wide Type 3 civilizations, using a huge fraction of their galaxy's starlight, appear to be absent in the data.
So, the math says could be crowded, and the telescopes say no obvious neighbours. That means we need explanations. Let's run the shortlist.
First, rare Earth. Planets are common. Our exoplanet catalogue makes that obvious. But complex, tool-using life might require a long chain of lucky breaks. A stabilizing climate, a protective magnetic field, the right chemistry, the right timing, and a lot of catastrophe that doesn't quite finish the job.
Depressing, but plausible. It solves the paradox by deleting most of the aliens.
What about the opposite? They're out there, but something stops them from ever becoming loud.
The great filter, the scary one. Somewhere between dead chemistry and galaxy hopping, there's a step that almost nobody clears.
And the question that matters is whether the filter is behind us or ahead of us. If it's behind us, maybe we already passed the hardest gate.
But if it's ahead of us, that's grim. It means civilizations reach a stage like ours, high energy, high leverage, high risk, and many of them don't stay stable for long. The silence starts to feel like a warning.
Let's pivot to something less apocalyptic. The zoo hypothesis.
The idea is that advanced civilizations exist, know we're here, and choose not to interfere. Like a cosmic nature preserve. No contact by policy.
It's also the conspiracy theory option, perfectly compatible with any outcome because it predicts nothing we can test.
Then there's the idea that everyone's listening, but nobody's broadcasting.
The dark forest intuition. What you see on screen. In a forest at night, do you shout your location or stay quiet because you don't know what else is out there? If most civilizations choose stealth over beacons, the galaxy could be full of listeners.
Which is basically us. We mostly listen. We've sent only a handful of deliberate messages, like the 1974 Arecibo message you're seeing on screen. And while some old broadcast leakage has declined, other signals, like radars, can still be powerful. Our radio footprint is changing, not simply disappearing.
So we have billions of years, hundreds of millions of plausible homes, and then the brute facts of distance.
Time and space really do matter. The Milky Way is about 100,000 light-years across. Signals move at light speed. Ships move slower. Civilizations might flare into existence, last a few thousand years, and go quiet, long before their signal ever reaches the other side of the disk.
Ships passing in the night. Except the night is measured in light years.
But doesn't the Drake equation try to put numbers on this?
It does, and on screen it looks neat. But it's more of a framework than an answer. We've gotten better at a few terms, like how common planets are, but other terms are still big unknowns.
Especially the brutal one, the fraction of planets where life starts. With one example, Earth, every value is still mostly a guess.
So here's our test in plain language. We have the capacity for life and the time for life, but not the evidence we expected. No confirmed signals, no confirmed megastructures. Aliens must be out there isn't impossible. It's just not proven by the numbers alone.
The silence is also data. We should treat it like data.
We're now roughly 3/4 of a century past Fermi's 1950 lunch walk. That's a long time for humans and a blink for the galaxy. The answer, so far, is still nothing confirmed.
And it's not for lack of tools. We throw modern computing at SETI data. We have the James Webb Space Telescope reading the chemistry of exoplanet atmospheres. We're getting better at the search, and yet, the scoreboard hasn't moved.
Let's do one last piece of math. Suppose just 0.1% of the galaxy's potentially habitable planets hosted a technological civilization. What does that mean?
Depending on which habitable estimate you use, 0.1% could mean hundreds of thousands to around 1 million civilizations in the Milky Way. Spread out, that's an average nearest neighbor distance of a few hundred light-years. Close in cosmic terms, but still not easy for us to detect.
Which loops us back to the uncomfortable options. Either that fraction is far smaller than we like to imagine, or civilizations don't stay detectable for very long.
So, is the Fermi Paradox proof we're alone?
No. Absence of evidence isn't evidence of absence. We've searched seriously, but we haven't searched exhaustively. It's like walking into a library, checking one aisle and declaring there are no books.
And I'll take the other side. I think the quiet might mean we're rare. Maybe not in the whole universe, but in this place at this moment. The Milky Way might not be crowded right now.
That's a heavy thought. If we really are the only ones,
then the stakes change. If life is common, Earth is one address among many. If life is rare, Earth is an outlier, maybe the only place in this galaxy where the universe is awake and asking questions.
Then we're carrying the torch, and if we drop it, the galaxy doesn't miss us. It just goes on, dark and quiet.
so the silence becomes less terrifying and more demanding.
Exactly. The Fermi Paradox is a mirror. If we're the ones asking, where is everybody, we also inherit a responsibility. Survive long enough to keep listening and keep learning.
And until we get a verified ping, or see something unmistakable on the scale of a star, we should act like we're the only crew on this ship.
Roughly 75 years since Fermi's question. More than 6,000 confirmed worlds on the books. And the biggest question still hanging there, silent. Thanks for staring into the void with us.
Keep looking up.
But don't hold your breath.